All right, part 1, 17.3, 17.4, delta G, E, and K. What in the world? Thermo is coming back. Delta G is negative N. And look at that. That's the potential of the cell times a Faraday constant. Delta G is negative RT ln K. You've seen that one before. And something called the Nernst equation. E of the cell. Look at that. Standard E of the cell minus RT in Faraday constant times ln Q. What in the world is going on? Okay, some good news about electro. All the electro you need to know for AP, we've almost covered it. We almost have. If the last video I went through, they give you a cell on the AP. They're going to give you a problem, a cell, and ask you everything about it, pretty much. And the calculations that we're going to today are going to be linking together electro, free energy, or electro, thermo, and equilibrium. So the good news is I'll go through problems again. I'm going to do a couple problems, and I want you to do 2 problems as well. The old number 1, which is a pretty easy one, I think if you go back, I say it is, but you need practice. And then the new one, that'll be like the one I'm doing now. Okay, so here we go. First, on the worksheet, where it says Nernst equation, delta G and K, it says a voltaic cell, and by the way, voltaic cell, electrochemical cell, they probably won't say the word electrochemical cell very much, but it could be used. But galvanic or voltaic cell. Remember Galvani and Volta? So all of these mean the same thing, basically. Okay, so if they say, here's a voltaic cell, it has zinc with zinc plus 2, that would be like either the cathode or the anode. We're going to figure that out. Zinc metal in zinc plus 2 solution, and magnesium metal in Mg plus 2 solution. These are the 2 half cells. What is the oxidizing agent? All that kind of thing. Okay, now they'll give you a list of possible equations you'd need to use. And so sometimes what they do is they might give you, like 3 metals. Like they might give you zinc and magnesium. Let me write them down first of all. Zinc equation, it should be kind of near the 1/3 from the bottom. Zinc plus 2 and 2 electrons. I'll put it over here. Zn2 and 2 electrons gives us zinc. And for that reduction, it's negative 0.76. So we saw that one in the last video. Okay? And then for magnesium, so I picked a little bit easier one here. I kind of like doing the ones where they're not the same ratio, but oh well. 2 electrons to give you magnesium. And for magnesium, it's even farther down, negative 2.37 volt. And so what they might say something like is, well, I don't know. I can't think. I can't make up something right now. But if I want to get to the lesson, but I could give you a third one here, and they could ask you some kind of question so that they would force you to use these 2. But oh well, we know that these are the 2 in the cell. So now, in the cell diagram, they want you to label all this stuff and tell, what are all the parts of the cell, and then calculate E of the cell, and then make some calculations with this. And you'll see, really, this stuff is pretty much just plug in the number and get the answer. But there is a little bit of short answer, possible essay on the Nernst. I'll get to that. Okay, and well, even for all of these, you'll see. Okay, so first, in the little cell, let's just say that this side is a zinc. A lot of times what they do is they will label one for you. This will be the magnesium metal. That way they can say clockwise, counterclockwise. So they probably will give you one of them already labeled, or both of them. But here is zinc, and it's going to be in I'll draw it the way they did. I'll draw a divider here. It's going to be in a zinc solution. Now, they didn't say what zinc nitrate or zinc chloride or what, but it doesn't matter. You have to have 1 molar zinc. That's one of the component questions they'll ask you. You need to have 1 molar zinc plus 2 ion. If it had been zinc nitrate, zinc chloride, doesn't matter. This side would have to be 1 molar magnesium plus 2. So magnesium is in Mg plus 2. All right. Now they did the little salt bridge for you, and we'll talk about that. And then they also, like I said, all you need to do is put a wire, and as soon as you connect the wire between the two, you'll see a spark. Okay. But they also put a little voltmeter here to tell you, and you'll write down what is the voltage right there. Okay. Like measuring it. Okay. So here we go. For my half cells, what will be the spontaneous cell reaction? Well, actually, they ask you some questions. What's the oxidation agent reducing, letter A, B, C? But I like to just go on when I see that for AP. If I see a problem like this, okay, I'm going to label that. I know that's true. That's got to be 1 molar. That's got to be 1 molar. Let's go and get the equation right now, because the equation will tell you what is happening, and it will answer most of the questions for you. So, which one is going to stay as written? Now remember, these are called reduction potentials. SRE. SRE, standard reduction potentials. Reduction, you gain electrons. Every reaction shows the substance gaining electrons over there. Okay? Now, the one who is the best at gaining electrons, the most spontaneous, or another word to say that is, the most thermodynamically favorable. That's the word they like to use instead of spontaneous on the AP. What's the most thermodynamically favorable of all of these? It would be fluorine gaining 2 electrons to give you 2F negative. That is the most favorable reaction to occur. So, look at these two. The one that is more positive. What's more positive? Negative 0.76 or negative 2.37? It's negative 0.76. Okay? That's it. Now, the one that's closer to lithium is magnesium. That's another way to look at it. The one closer to lithium has to be flipped. But we see the one that is more positive, which is this, is going to stay as written, but the other one gets to be flipped around. So this, instead of being magnesium gaining 2 electrons, it's going to be magnesium losing 2 electrons to give you Mg plus 2, and that becomes positive 2.37. We'll make it positive there. Okay, so we can go on and add them up. This is a fairly easy problem because 2 electrons on the left and 2 on the right. If it had been only 1 electron here, you have to multiply this all by 2. But remember, you never multiply the voltage by any number. If I'm multiplying all this by 2 or 3 or 5 or whatever, you never multiply the voltage. Only these numbers. But these two are already worked out well. And the other thing, I didn't do it here. I told you I try to always line up the arrows on all my equations. That way, I won't accidentally put the wrong thing on the wrong side. So zinc plus 2 electrons. Okay, I just made a mess, but it's the same thing I had written before. I just wanted you to be clearly able to see that 2 electrons on the left, 2 electrons on the right, they're going to cancel out. Some people put them down here as well. So zinc plus 2 plus magnesium gives you zinc plus magnesium plus 2. And the E of that cell, the standard cell potential in voltage, the voltage of the standard cell is 2.37 minus 0.76, 1.61 volt. So, it's a 1.61 volt battery. I had another piece of chalk here. I thought it might be better if I'm going to add something on here, I'll use another color this time. Last time I didn't. Let's just see if that makes it a little bit easier to see things. I'm going to add into it. Okay, so what happens in this cell? Well, this tells you, every equation tells you the whole thing. In fact, I told you, write the equations right here. I probably would have even written them before this, but sometimes they ask you, that's 1 molar and that's 1 molar. In a standard cell, when you see the E degree sign, E degree. Okay, I'm going to put zinc. On the zinc side, you have this going on. Zn plus 2 electrons gives you zinc. On this side, you have Mg, and it is releasing 2 electrons and becoming Mg plus 2. Okay. So the equation tells you everything. Remember this. Whenever you see a metal with no charge, it's always a solid at room temperature. That magnesium is a solid. The only one that's not is mercury, and mercury is not on this list. Mercury could be used but it will be a liquid, but still, the main thing is it's not a charge. It has they're all solids. These are precipitate solids. That is aqueous ion. I don't think they're going to use mercury, actually. Okay. All right, so here we go. So can you tell, is this Leo or Ger? I am Ger, gaining electrons reduction. I'll put it over here. This is the reduction half cell. This must be the oxidation. But how do you know it's oxidation? Because magnesium loses electrons. You see, electrons are a product. So that's the Leo cell. It's the oxidation. Lose electrons, oxidation. Half cell. So I'm going through everything again. In fact, I told you to do the old number 1 for homework and then do the new thing with the equations. If you had a little bit of problem with this, after I go over actually what I've done right now, you could almost go and do that problem. After I do this problem, I'll tell you, you could stop the video and go and do that number 1 problem. Then come back to the video and I'll show you the other part. Okay, however you want to do it. Okay, or just remember, write down the numbers where it was. Okay, now let's just go on and answer the questions now. But I like to tell you a few other things. I like to label down there like the mass. What happens to the mass of the zinc electrode and the magnesium electrode? What happens to the molarity of the zinc ion in this cell or in that cell as time goes by? As soon as you connect it, what happens to the molarity? Is it going up or down? One increases in mass, one decreases in mass. One goes up in molarity, one goes down. Oh, one more thing. Is this the anode or the cathode? Reduction, remember, in English, the consonants are C. Cathode reduction. So this is the cathode. And this is going to be the anode. The anode consists of magnesium in magnesium solution. You might have seen it written like magnesium, a line, Mg plus 2. The cathode consists of zinc and plus zinc in a line and zinc plus 2 solution. I don't think they use that notation much on the AP, but you might see it in my notes. And I kind of skip through it in the notes too because it's in the book, but they don't really. And then to write the entire cell, if you really wanted to see it at least one time, they say, here's your cathode. And they put 2 lines, and here's your anode. That's just a notation, a line notation to indicate this electrochemical cell. But there's no need. I don't think you have to worry about that. They're not just going to throw that on the AP and say, do it. What? Do what? They're going to ask you as I'm showing you here. But that's just the way the book does it. And AP could show you that, but then they would let you know what you're talking about. They're not going to make your grade based on understanding the line notation of it. All right, here we go. So we'll start answering the questions. It says on the first question, A. All right, number 1. The oxidizing agent is what, and the reducing agent is what? Okay, one is oxidized, one is reduced. The one that is oxidized loses electrons. So this is anode oxidation. This is oxidized, right? Oxidation half is oxidized. So that means it is the reducing agent. The reducing agent. It is the reducing agent. So this one, since it is oxidized, it reduces the other thing. This one would be reduced. So it is the oxidizing agent. It is the, okay. This one is reduced, so it is the oxidizing agent. Isn't that weird? Okay. Okay, so in the oxidizing agent, we just said, is zinc plus 2. The reducing agent is going to be magnesium, Mg, just Mg. In the reaction, what is oxidized? We wrote there, oxidized magnesium. Magnesium is oxidized. How do we know that? Because it goes from 0 to positive 2. And it even says that its charge changes from 0 to positive 2. You know, on the AP, they ask this a lot. And they don't give you fill in the blank. They'll just say, which substance is oxidized? Justify your answer. That's how they do it on the AP. So I should have done it there too. But you might want to remember this. So which one is oxidized is magnesium because its charge changes from 0 to positive 2. And you can even write that equation. If it will probably be on your paper anyway. But that will be good enough. All right, which one is reduced? It would be zinc plus 2 because its charge changes from zinc positive 2 down to 0. It decreases. Remember, the one that is reduced, its charge is reduced. That's an easier way to remember it. Write the balanced equation for the oxidation half reaction and the reduction half reaction. Label each, okay? Then write the balanced net ionic. So which one of these is the oxidation half? Well, that's easy. That's the oxidation half cell. That's your oxidation half reaction. So you'd have to write that. I don't want to make a mess here, but oh well. This is your oxidation half cell or half reaction. Oxidation half reaction. This is your reduction half reaction. So reduction half reaction is this. Oxidation half reaction is this. Okay? Of course, if it's on your AP exam, make it, don't use a little RXN. I just did that for there, but don't do that. But write it out. Oxidation half. Well, oxidation half, reduction half is probably enough. You probably can do that. But okay. All right. Now, and calculate the cell potential, E of the cell, for the spontaneous reaction. And we got that. It's 1.61 volt. And you had to know, mainly, because magnesium was flipped, that equation, that became a positive 2.37. And there it is. Okay. Now, at this point, I've almost done everything, but let me answer 2 more questions that are not on the paper. And then, if I answer these 2, you'll be able to do the old worksheet if you want to jump to that right now. Okay, so first, they didn't talk about the salt bridge on this problem, but let's just make it be, let's use sodium or potassium, or how about lithium? We never use lithium. Let's use lithium plus 1, and how about chloride? Why not? I'll just make that up. Lithium and chloride in the salt bridge. Okay, so the first question they might ask, what happens to the mass of the zinc? Well, does it increase or decrease? The mass of the zinc anode, it's cathode. I'm so sorry. Or you know what they might say? They won't say that because that will give it away. It is the cathode. They'll say the zinc electrode. Electrode is a general term. The mass of the zinc electrode is going to increase. Can you see that what happens in this cell is zinc ions are going to join? They're going to get electrons here. They're going to gain, and they're going to join onto the side. It's going to get more and more zinc formed. So zinc ions gain electrons and form solid zinc, and they're going to go onto that. So the mass of the zinc electrode increases. All right, the mass of the other one, the magnesium electrode, decreases. That should be the opposite of the other one. And the equation tells it all. Here's the magnesium solid, but it goes to magnesium plus 2. So as time goes by, you're making more Mg plus 2, more Mg plus 2, more Mg plus 2. As time goes by, the zinc ions are going away. Okay, think about that. So that I just answered the next question. What I'm going to make up here? Zinc plus 2 concentration. The molarity of the zinc in this cell, it started at 1 molar. It decreases as time goes by because the zinc's ions are making solid zinc. But the magnesium ion concentration is going to increase because look, the solid is going to be reacting and magnesium ions are coming off. It gets smaller and smaller. We'll just make it like that or something. It's going to be leaving. So it's going to increase its molarity. Okay. Now what happens? There was a question that said, use arrows to indicate what does a salt bridge do? What's happening in the salt bridge? Movement of ions. Since you're losing positive ions in this cell, that means that lithium ions are going to come out. So I'll draw a little arrow and I'll put Li plus 1. Or you can say lithium plus 1 goes out. So the lithium will go out on this side. On this side, you're gaining more magnesium. In fact, here's a good thing that I just accidentally kind of can do. For every magnesium ion that breaks off, you're going to have 2 chlorines. 2 Cl negatives are going to migrate out. And that's the word they use, is migrate. So like lithium ions, there'll be billions and billions of lithium ions and billions of chloride ions in here, but lithium ions will migrate out into the cathode to balance keep the neutrality, to keep, well, we'll say charge balanced. You don't want to lose. You can't have the positive goes away. It's becoming too negative here. So to balance the negative, you'll have lithium ions coming in, and actually it's the same thing that for every zinc ion you lose, you'll get 2 lithium ions out because you're +1, those are +2. So every zinc ion that goes away, 2 lithium come out. For every magnesium ion that dissolves, you get 2 chlorides will come out. Okay, that answers all the questions that you see on the old lesson we did, if you want to go back and do the old one right now. And then I'm going to move forward and show you the next part. But I'm going to have to, let me see. I'll make a little stop here, a break here. But then what I'm going to do in the next video, I'm going to start with the E of the cell, and I'm going to show you how to use these calculations. And that's just about almost all of this type of cell you need to know. We're more than halfway through electrochem, so you'll be amazed. Electrochemistry is not real long, but look at how much you have to know for one cell. But over and over again, practice makes it better. I'll see you. All right.